Today we'll be discussing on the numericals which are related to construction equipments. There are different construction equipments like concrete transit mixers, scrapers, graders, earth hauling equipments, etc., which are used on a large scale in the construction industry. So to begin with our problem, the first problem what we will be dealing with today is the transportation of concrete. The number of mixers which are required for a transportation of concrete, and for which we have assumed a data wherein the capacity of the truck is 6 m cube. The loading time, the travel time for a loaded truck from the site to the construction site, that is from batching plant to the construction site, average waiting time at the site, the discharge time, the travel time, all those datas are given, and if you sum up all these datas you can get the total cycle time. In order to calculate the number of mixers, the formula is the cycle time upon discharge time plus one spare truck has to be kept in emergency, and the total that is cycle time what is given here is 49 minutes, and the discharge time what is given is 15 minutes. Together it comes, if you divide 49 by 15, you get 3.26 plus one spare truck, that is it comes to 4.26, and we have made it we have to round it off to 5. So the number of trucks required in this particular case is 5 trucks. Coming to the next problem, that is based on graders. In this we are supposed to calculate the time required to grade and finish a road whose length is 30 km and width is twice the width of the motor grader. So the data what is given to us is the length of the road which is given to us, that is 30 km. The width is given, that is 3 times the grader width, and we are supposed to have 6 passes. 6 times we are supposed to have the rolling over it with different speeds, that is 2 passes of 6 km per hour, 8 passes of 8 km per hour, and 10 km per hour will have 2 passes. And we are also assuming the efficiency of machine based on the operator skill, machine characteristics and working conditions. It is assumed as 75%. Now in order to solve this problem, what we have to do is we have to calculate the average speed of the grader or the roller, wherein we know that there are 6 passes, 2 passes of different speeds of 6, 8 and 10. So you have to multiply 2 into 6 plus 2 into 8 plus 2 into 10. These are the speeds and the passes. The number 2 is each pass or 2 passes divided by 6. That gives us, that is 6 is the total number of passes, gives us the average speed, that is 8 km per hour. Now the area to be graded per hour, we have to calculate the area, that is going to be the width graded per hour into average speed into machine efficiency upon number of passes. And we know that the width per hour and other things we have already calculated the average speed. Width is unknown to us, it is 3 times the width, that's why we have considered right now it as a W, that is width into 8 is the speed, and since the speed is given in kilometer per hour and the width of the road will be in meters, we have multiplied it with 1000 multiplied by the efficiency, that is 75%, upon the number of passes, that is 6. So the total area to be now we'll be moving to the next part. This will be something, answer will be in terms of W. The number of hours required to grade and finish 30 km long 3 times the width wide area will be the total area upon area per hour. That's how we come to know that the 30 km has been converted into meters into the width, that is 3W, upon the area to be graded per hour. So we come to a conclusion that we require 90 hours to grade this area. Coming to the next problem on earth hauling equipments. It is the construction of a military helipad at an altitude of 2400 meters, which involve 80,000 cubic meter of loose area excavation in soft soil. This task has to be completed in 200 working hours. So the area, the quantity is 80,000 cubic meter and the timing what is required is 200 working hours. The company entrusted with the execution of the task as 2 dosers. I am just stressing on 2 dosers, that the number of dosers what are required is 2, each with an output of 220 m cube per hour. So the output is also given to you as 220 m cube per hour under job conditions. It also holds a wheel loader and 22 m cube dump truck. One loader can load about 120 m cube of excavated soil per hour in a truck. So the dump truck cycle time for a disposal of excavated material is 35 minutes. This includes 7 minutes of loading time by a loader consisting of 2 loaders. So the excavated material has, the disposal time is given as 35 minutes, which also includes 7 minutes. That is also given in this problem. And we are supposed to estimate the output of front end loader for loading excavated soil into dump trucks and determine the approximate quantity of dozers, loaders, dumpers required to complete this particular task. So some of the data which is given to us. Now if you go to the number of dozers what is required, it is excavated quantity upon output per hour into working hours. Excavated quantity is already given to us as 80,000 cubic meter. The output per hour is also given to us as 220 m cube per hour, and working hours are also mentioned to us as 200 working hours. So by which we will come to know the number of dozers what are required. That comes to 2 dozers. In some cases I will directly round it off to the higher digit. The second part in this problem is loaders required. So excavation per hour by a dozer upon loader output is the formula. Now excavation per hour by a loader, this particular part has been again bifurcated. To calculate the excavation per hour by dozer, we require the number of dozers and the output of dozer per hour. So based on the first part, the A part, we have calculated we require 2 dozers. So that part is included here, 2 into 220. That is the output of 1 dozer is already given in this problem, divided by loader output. The loader output is already given, that is 120 m cube of excavated soil per hour is already given to us. So by which we can calculate the number of loaders required. Only data what was required here was number of dozers, which we have already calculated in part A. Coming to the last part, that is the dumpers required. We have a formula 1 plus dumper cycle time upon loading time. Why 1 is in case of, that is 1 is a spare dumper what is required in case of emergencies, because we have to ply the dumpers on a longer routes. Now by which we know that we require the dumper cycle time what is given to us in the problem is 35 minutes, and the loading time is also given to us as 7 minutes. 1 plus 35 by 7 will give us 6 dumpers in one cycle. We have 2 cycles what are given in the problem, by which we come to know that we require 2 into 6, that is 12 dumpers. Coming to the next problem on scrapers, there is we are supposed to evaluate the output per hour after making some adjustment in various factors. And in this problem what is given is scraper capacity is given, that is 16 by 23.7, that is stuck by heap capacity is given. Gross vehicle weight, that is empty weight, is given as 36 ton. Maximum payload is given as 34,020 kg. Material density is also mentioned to us as 1,500 kg per m cube. Job efficiency is 50 minutes per hour. Power of an engine, that is rated power of the engine, is 450 HP, and the correction factor is 0.9, which is we get from the equipment manual. Now in order to go further to this problem, what has been done is production per hour in loose condition is calculated, that is load per cycle into 60 into operation efficiency.
by which load per cycle we can calculate is heaped is equal to heaped weight of the heaped capacity, that is 23.7 m cube into 1500 kg. Now both the things, that is 23.7, that is the heap capacity is already given and material density is already given, that is 1500. If you multiply, we'll come to know the what is the loose quantity, that comes to 35,550 kg. But what is given in this problem is the maximum load which can be carried out is 34,020 kgs. Therefore, maximum load carrying capacity will be 34,020 divided by the material density, that is 1500 in loose conditions. So it comes to 22.68 LCM and not 23.7, which is already given in this problem. So there is an adjustment to the load carrying capacity. So now moving further, the ideal production per hour is 16 cm, that is 16 cubic meter, what is given as a struck capacity in the problem, with 23.7 heaped capacity, and we have calculated the ideal production per hour for 16 cm, the cubic meter, that is struck capacity of the scraper with 23.7 heaped capacity, is given as 150 LCM. Now this 150 we have calculated from the graphs which are available on the textbook. So also, if you, in some cases the charts are already given in the problems, or the values are given in the problem. We have also the correction factor, what is already given in this problem is 0.81, and the performance factor what you can see of 0.84 is, we have referred the charts. Now the load carrying capacity is maximum load carrying capacity upon scraper heaped capacity is the formula. The load carrying capacity is 22.68. We have already calculated the maximum load carriage capacity, which was that 34,020 upon 1500 divided by the total capacity of the heap capacity of the scraper, which is given in the problem. Here it is 22.68 by 23.7, out of which 22.68 we have already calculated, whereas 23.7 is given in the problem. So therefore the scraper output will be 150, that is ideal production capacity, which we can get from the graphs. 0.91, that is a correction factor which is already given. 0.84, this is the performance factor which we can get from the tables, and 0.96 is what we calculated, that comes to 110 LCM per hour is the capacity, the output per hour. Coming to the next problem, that is on bulldozers. It is to determine the output of the bulldozers having 215 HP engine, which is fitted with A blade with a rated capacity of 4.40 m cube. The dozer is employed for excavating hard clayey areas with average haulage of 50 meters on ground with a downslope of 10%. It has a direct drive transmission. It is expected performance is 50 minutes per hour. So what is given to us is the output of a bulldozer we are supposed to determine. The capacity of the engine is 215 HP. The A blade is provided and the capacity of blade is 4.40 m cube. The dozer is employed for the excavating hard clay areas and haulage is 50 meters. The downslope is 10% and the performance expected performance is 50 minutes per hour. So based on this is the sum of the data what is given. The output per hour is equal to ideal output per hour into correction factor into performance factor. Now the ideal output for 50 meter haulage of 215 HP dozer with S blade of capacity 4.4 m cube, that is from data sheets what we have obtained is 160 LCM. This is approximate. This is what we obtained from the data sheets which are available on different textbooks. The correction factor which is also applicable, since we are going for the data what is obtained is of S blade, that is 160 LCM is of S blade and not A blade. In our case we have been given a blade, so what is to be done is we have to go for a correction factor. We have a soil factor for hard digging, that is 0.61, blade factor for A blade is 0.65, the grade factor for 10% downgrade is calculated, that comes to 1.25, transmission factor is 0.8, swell factor for clayey soils, because our soil what is mentioned in the problem is a clayey soil, it is 1.3, and the correction factor is multiplying all those things, that is 0.67, which is the soil factor for hard digging, multiply by blade factor, multiply by the grade factor for 10% downslope, multiply by transmission factor, multiply by swell factor. Now a care has to be taken that while multiplying a swell factor, it will be 1 divided by the factor, and that's how it comes to total comes to 0.34. Now the performance factor for 30 minutes of working is 50 minutes per hour working is equal to 0.83, which is already given in the data sheets. So therefore the output what we can obtain is bulk cubic meter is 160 into 0.34. What we obtain the correction factors multiply by performance factor of 0.83, it comes to 45.15. Say it is 46 bulk cubic meter. Coming to the next problem on backhoe. In this we are supposed to estimate the early production in a bulk volume of a backhoe with a bucket capacity of 0.96 employed on a excavation of foundation 4 meters deep in a hard digging soil. The excavated earth is to be loaded in a waiting dump truck which is placed at a swing angle of 75 degree. The expected performance efficiency is 83%. So we are supposed to calculate the ideal output in loose cubic meters for equivalent face shovel of a bucket capacity 0.96, and since the bucket capacity of 0.96 m cube is given to us, and we get the ideal output from the tables which are given, it is 120 loose cubic meters, that is approximate. Now what we have to do is the backhoe output using the equipment conversion factor is 0.8 operating at a minimum depth. So we come to know that it is 120 LCM into 0.8, that comes to 96 LCM. Now coming to the next part, the correction factors. There are different correction factors which we are supposed to apply. That is soil factor for hard digging, load factor for loading into vehicles, swing factor for 75 degree. All those things are already available on the data sheets, and we have to just multiply all these things. We get an answer of the correction factor is 0.56. Now if you see here in the first part, that is backhoe output, it is 0.8 is given from the charts. Now the last part is the performance efficiency is 0.83, which is already given to us in the problem, and we are supposed to calculate the expected output, that is the ideal output multiply by correction factor multiply by performance efficiency. In this ideal output is already given to us, that is 120 multiply by 0.86, because we had to do a adjustment or a correction for a backhoe, and that's how it is it is 96 multiply by the correction factor, that is 0.56, and the performance factor which is 0.83. There together it comes to 45 loose cubic meter per hour is the output, expected output per hour of the backhoe. Thank you.